Hi, boys and girls. Welcome to math for this week. So today is Monday and we're starting a new lesson. Okay, we're going to be doing lesson 22, which is multiplying fractions and word problems. Right now, I'm just going to do a little warm-up with you, so you don't need to worry about looking in your book just yet. You can just follow along with me up here, okay? So the target, or the reason why we're doing this, is because we want to learn how to represent real-world problems, so things that could actually really happen to us, involving multiplying fractions and mixed numbers, using visual models and equations, okay? So I put two examples up here that we're going to do for a warm-up, okay? So the problem is, lovely Mia had 5/6 of a bottle of milk left in her fridge. So that means Mia has a bottle of milk, maybe similar to this, and there's only 5/6 of it left. Okay, she's drank some, and 5/6 are remaining. Jacob asked if he could use half of that milk for his cereal. How much of the original milk did Jacob use? Okay, so I know when I'm working with word problems, I really need to be making sure I'm using the right operation, right? Because it's up to me to figure out how I have to solve this problem. So, Mia has 5/6 of a bottle of milk. 5/6. I might even underline that. Jacob asked if he could use 1/2 of that milk. I know of means multiply. So I'm multiplying times 1/2. Okay, I'm going to multiply right across. 5 times 1 is 5. 6 times 2 is 12. So this means that Jacob used 5/12 of Mia's milk. How nice of Mia to let Jacob borrow that. Now, for the next one, we have Amaya. She's doing some painting, okay? She has 3/5 of a container of paint left. So she's used some. Now she has 3/5 left. Kaylee asked to use 2/3 of the paint for her project. How much of Amaya's paint did Kay use? Okay, I need to figure out how much of Amaya's paint, which was 3/5 of the container, did Kaylee use if she used 2/3 of the paint? I need to multiply. So 3 times 2 is 6. 5 times 3 is 15. Okay, this means that Kaylee used 6/15 of Amaya's paint. Great sharing, girls. Okay, now we're going to move on to the RCC book. So I need you to open up to page 437. And remember, you guys know the drill now. So if you need me to slow down because you need some time to get something out or something, just pause me, okay? So, marker. This is my problem on page 437. It says, Grayson lives 4/5 mile from the park. And when I'm reading word problems, I'm really thinking about what this stuff means. So he lives 4/5 of a mile. I know 4/5 is not a whole yet, right? It's less than a whole. So he lives a little bit less than 1 whole mile from the park. He has already walked 3/4 of the way to the park. How far has Grayson walked? Use a visual model to show your thinking. Okay, it's asking me to show a visual model, so that means I need to do some sort of picture or diagram. One type I like to use is an area model. So we're going to go ahead and do that, okay? So I'm going to get myself started to do an area model by making a square. Everyone should do this in their RCC book, please. Now, he lives 4/5 of a mile from the park. And he's already walked 3/4 of that amount. So that means we need to multiply. So on one side, we're going to have 4/5, and on one side, we're going to have 3/4. Okay, now I need to break up my area model. So 4 out of 5, right? That means I need 5 rows. So I'm going to go ahead and make 5 rows. Okay, let me just double check that that's 5. 1, 2, 3, 4, 5. Good. How many of those rows do I need to shade? 4 out of 5. Right, so I'm going to quickly shade in 4. Okay, that's my 4/5. Now I need to represent 3/4. So it's 3 out of 4. So that means I know I need to break this up into 4 columns. That's my denominator. When I break things up into 4, I like to do this because I know that half of 4 is 2. So I can break it in half like this. And then I can just break these chunks in half. So it's as even as I can make it, right? Is that 4 columns? 1, 2, 3, 4? Sure is. Okay, how many of those columns do I need to shade? 3 out of the 4. So I'm going to go down and shade in 3/4. Okay. Now, the way I find my answer or my product in using an area model is I see which squares have both shading in them. How many overlaps? So I notice these guys here are overlapping, right? I'm going to go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 are shaded in both colors. And what is my 12 out of? Well, that's the amount of squares that's in the entire area model. So instead of counting all those, I know that there's 5 rows and 4 columns, so I can multiply that. 5 times 4 is 20. Okay? Something tells me I'm not done because these are pretty big numbers, and I notice they're both even. If a number is even, that means 2 can always go into it. So I'm going to simplify this. This is what we practiced last week, okay? So when I simplify, I'm going to divide the numerator and the denominator by the same number, which is going to be 2. So divided by 2/2. What is that going to get me? So 12 divided by 2 is 6. 20 divided by 2 is 10. Wait a second. Those are still even. So I could simplify it even more. That means I can divide by 2 again. Divided by 2/2. 6 divided by 2 is 3. 10 divided by 2 is 5. So that means that, what's his name? Grayson has 3/5 of the way left. Okay? Excuse me. That means he's walked 3/5 of a mile. Okay? So that's page 437. Please turn to page 438. We are just going to look at problem 2. Okay? So we're looking here at problem 2. I'm going to write it on the side so it's a little bit bigger, okay? But you're going to write it in your book. So it says, you can use what you know about multiplying fractions to think through and solve word problems involving fractions. Consider this word problem. It says, Aaron spills 1/2 of a 3/4 pound box of cereal. How many pounds did she spill? Okay, she spilled 1/2 of 3/4. So by that keyword of, I know I'm going to be multiplying. So for A, it says find 1/2 of Finding 1/2 of a quantity is the same thing as multiplying by 1/2. What equation could you write for the cereal problem? Use P for the unknown amount in the problem. So it's asking me what equation I can use. So I'm not solving it just yet. I'm just showing the equation. So underneath A here, we're going to be writing that. Well, my equation is going to be 1/2 of, which is the same thing as multiply, 3/4 equals, it says P is the unknown amount. So we don't know the answer yet. So that is going to be P. Okay? I bet they did P for product. Okay. Now, B. It says estimate. So I know when I estimate, I'm thinking about what it's going to be really close to. Estimate the product. Is the amount of cereal Aaron spills on the floor more than 3/4 of a pound or less? And why? Okay, so this was a rule from last week. I remember the rule was, if you multiply a number or a fraction by a fraction that's smaller, your answer is going to be smaller than the original amount. If you multiply a number or fraction by a fraction that's greater, your answer is going to be greater than the original amount. Okay? So, we are multiplying 3/4 times 1/2. That means to tell if my answer is going to be less than or greater than 3/4, I need to determine, is 1/2 less than 3/4 or greater? If you're not sure, you could draw a little picture. So here's 1/2, and this is 3/4. You don't have to draw this picture if you just want to look at it, that's fine. So, is 1/2 greater or less than 3/4? I hope everyone said less than, right? So, this means we can write we can say Aaron spills less than 3/4. I'm going to say LBS for pounds, less than 3/4 of a pound, because 1/2 is less than 3/4. Okay? If you want to pause me and get that down, go ahead. But I'm going to move on to C. So it says, complete the area model to show the problem. How many pounds of cereal did Aaron spill on the floor? So the area model it already showed me has, I'm just going to erase this because, sorry, friend. It has 3/4 on the top here. And I'm lucky because they showed me I already need to break this into 4 columns, right? So that's what you guys already have. It's right here. Now, what am I multiplying this by? I'm doing 3/4 times 1/2. So this is going to be 1/2 over here. How many rows do I need to break this into? 2 rows. So I'm just going to go like this. Boop. 1 row, 2 rows. Okay. Now I need to shade. How many of the 4 columns do I have to shade? I need to shade 3. Use a different color. So I'm going to shade 3 of my columns. Okay. How many of my rows do I need to shade? I only have to shade 1. Okay. So now my product is going to be the squares that have both shading. How many have both shading? 1, 2, 3. And how many are there all together? 2 times 4 would be 8. So that means Aaron spilled 3/8 of a pound. You would put that right here. Okay? Next, take a minute to get that down if you need to, because the next thing you're going to do is go to page 440. Here's page 440. We're only going to do problem 3. Mrs. Jones was nice and didn't have us do every single problem. Okay, so if you're on page 440, you're going to read along problem 3. It says, Lola lives 3/4 of a mile from the basketball court. She has already walked 2/3 of a way to the basketball court. How far has Lola walked? Use a visual fraction model to show your thinking. Okay, so I'm going to be using mostly area models, boys and girls, because I think that's been the easiest technique. If you want to do it on a number line, you can also do it on that, okay? So let's do an area model here. So we have that Lola lives 3/4 of a mile from the basketball court. She already walked 2/3 of that mile. Okay, so I need to break this up. How many columns do I need? 4. How many of those columns should I shade? 3 out of the 4. Okay, I'm going to do this all in one color this time because that's what you're probably doing, so I'll just show that as well. Now for rows, how many rows do I need? 3. How many of those rows do I need shaded? 2. So since I'm using the same color, I'm going to just do my hash marks in a different direction. I'm going to do them like this. Okay, now to find my product, I'm looking for the squares that have my overlapping hash marks. So I can see pretty clearly it's 6, right? 6 out of how many are in my whole entire area model? It's going to be 3 times 4, which is 12. 6/12. I actually know that 6/12 is equivalent to 1/2 because 6 is half of 12. So I'm going to simplify that and say 1/2. So that means that Lola has walked half the way to the basketball court. Okay? This is the work that you're going to be putting here. Okay, boys and girls, so please take a look at my slide deck and see what you need to do next for math today.